Space, the final frontier. It's vast, it's mysterious, and it's incredibly far away. Our current spacecraft are like tiny rowboats trying to cross an ocean. Even reaching our closest stellar neighbor, Proxima Centauri, would take thousands of years. But what if we could cheat the cosmic speed limit? What if we could fold space itself, like a piece of paper, and travel vast distances in the blink of an eye? This is the tantalizing promise of warp drive. Warp drive is the ultimate dream of science fiction, allowing us to explore the galaxy and encounter alien civilizations. But could it ever be more than a fantasy? Surprisingly, the answer might be a cautious, but hopeful maybe. The concept of warp drive is most famously depicted in Star Trek. The Starship Enterprise, with its sleek design and iconic warp nacelles, captured the imagination of generations. In the Star Trek universe, warp drive works by creating a warp bubble around the ship. This bubble distorts space-time, compressing space in front of the ship and expanding it behind. The ship itself remains within a normal space-time bubble, allowing it to travel faster than light without violating any physical laws. Star Trek's portrayal of warp drive, while entertaining, is based on fictional technologies like dilithium crystals and warp coils. However, the basic idea of warping space-time has its roots in real science. Albert Einstein, in his groundbreaking theory of general relativity, revolutionized our understanding of gravity and the universe. He showed that gravity is not merely a force acting at a distance, as previously thought, but rather a curvature of space-time caused by the presence of mass and energy. Imagine a bowling ball placed on a trampoline. The ball creates a dip in the fabric, and if you roll a marble nearby, it will curve inward towards the bowling ball, illustrating how mass warps space-time. This is similar to how gravity works, with massive objects like stars and planets warping the very fabric of space-time, bending light and affecting orbits. Einstein's theory also allows for the possibility of space-time being warped in more extreme ways, potentially even creating shortcuts through the fabric of the cosmos, known as wormholes. This is the theoretical foundation upon which the concept of warp drive rests, a fascinating idea that could one day enable faster-than-light travel across the universe. In 1994, Mexican physicist Miguel Alcubierre proposed a theoretical model for a warp drive, now known as the Alcubierre drive. Alcubierre's solution to Einstein's equations showed that it was mathematically possible to create a warp bubble. This bubble would compress space-time in front of the spacecraft and expand it behind, effectively creating a wave that the spacecraft could ride. Imagine a surfer riding a wave on the ocean. The surfer moves faster than the water itself by riding the wave's energy. Similarly, a spacecraft using the Alcubierre drive would be propelled forward by the warping of space-time itself, potentially achieving faster-than-light travel without violating any physical laws. Section 5. Exotic matter, the key to the impossible. There's a catch, of course. The Alcubierre drive requires a substance called exotic matter with negative mass energy density. This type of matter is hypothetical and has never been observed. Think of regular matter as having positive energy density. It takes up space and has weight. Exotic matter, on the other hand, would have negative energy density. It would effectively create a repulsive gravity that pushes space-time apart. While the existence of exotic matter is still purely theoretical, some physicists believe that it might be possible to create or harness such matter in extremely small quantities, perhaps using quantum effects. Section 6. A universe of energy powering the warp drive. Even if we could create exotic matter, the energy requirements for a warp drive would be astronomical. Initial calculations suggested that powering the Alcubierre drive would require more energy than the entire observable universe contains. However, more recent research has shown that these energy requirements might be significantly lower than initially thought. Some physicists believe that manipulating the shape of the warp bubble could reduce the energy needed to a more manageable level. Still, we're talking about energy scales far beyond anything we can currently produce. It would likely require harnessing the power of entire stars or even black holes to generate the energy needed for a warp drive. Section 7. Engineering challenges building a warp bubble. Beyond the theoretical hurdles, the engineering challenges of building a warp drive are equally daunting and complex. Creating and manipulating exotic matter, if it even exists, would require technologies far beyond our current capabilities and understanding. Then there's the critical issue of stability. The warp bubble itself would need to be incredibly stable to prevent the spacecraft inside from being ripped apart by the extreme forces involved. We'd also need to develop sophisticated navigation and control systems to steer the warp bubble and avoid collisions with interstellar objects. Remember, at warp speeds, even a tiny dust particle could spell disaster for the entire mission. Section 8. Time travel and paradoxes. The price of warp. Faster-than-light travel opens up a Pandora's box of potential paradoxes and ethical dilemmas, challenging our understanding of the universe. If we could travel faster than light, would we be able to travel through time as well? This question has fascinated scientists and dreamers alike. What would happen if we went back in time and accidentally altered the past? The consequences could be unimaginable. These are questions that physicists and philosophers have grappled with for decades, pondering the very fabric of reality. While the possibility of time travel is still highly speculative, it's a topic that cannot be ignored when discussing the implications of warp drive and its potential. The ethical considerations are equally complex, involving moral questions that humanity has never faced before. If we develop the ability to travel to other star systems, how will we interact with alien civilizations? The stakes are incredibly high. Will we be welcomed as explorers or feared as invaders? The future of interstellar relations hangs in the balance. Section 9. Current research and future prospects. Despite the immense challenges, the concept of warp drive continues to intrigue scientists and capture the public imagination. While a fully functional warp drive is still firmly in the realm of science fiction, there are glimmers of hope on the horizon. Researchers at NASA's Johnson Space Center are exploring the theoretical possibilities of warp drive through their Advanced Propulsion Research Program. While their work is still in its early stages, it represents a serious attempt to bridge the gap between science fiction and reality. Other physicists are investigating alternative theoretical frameworks for faster-than-light travel, such as wormholes and Krasnikov tubes. While these concepts also present significant challenges, they offer alternative avenues for exploring the cosmos. Section 10. Conclusion: a warp drive in our future. The development of a warp drive, if it's even possible, is a challenge of extraordinary proportions. It's a concept that stretches the limits of our imagination and scientific understanding. It would require breakthroughs in our understanding of physics, potentially rewriting the very laws that govern our universe. The development of revolutionary technologies, ones that we can scarcely conceive of today, and a willingness to confront the ethical and philosophical implications of such a profound discovery. However, the potential benefits could be immense. The human spirit of exploration and our thirst for knowledge are powerful motivators. Our history is filled with examples of overcoming the impossible. Just as the Wright brothers dared to dream of flying machines, defying the skeptics of their time, and astronauts ventured into the unknown depths of space, pushing the boundaries of human capability. Perhaps one day we will unlock the secrets of warp drive and embark on journeys to the stars. This would mark a new chapter in human history, The universe is vast and full of wonders waiting to be discovered. Each discovery brings us closer to understanding our place in the cosmos. While warp drive may seem like an impossible dream today, a mere figment of science fiction, who knows what incredible technologies the future holds? The pace of technological advancement is accelerating. As we continue to push the boundaries of science and engineering, exploring new frontiers and challenging our limits, the dream of faster-than-light travel may one day become a reality, transforming our approach to space exploration, opening up a new era of cosmic exploration for humanity. The stars may not be as far away as they seem.